Hi, chemistry students, and welcome to the second class of week 9. For today, we are going to talk about how to identify the physical and the chemical properties, how to differentiate between chemical and physical changes. Take care while I'm speaking about the changes. And the last or the third learning goals, we want to learn about how to write chemical equation. So let's start about and chemical properties. When I'm speaking about physical properties of the matter, that I'm talking about the characteristics of the matter, which is observed, but there is no changing in the identity of the substance. For example, when I'm talking about the color of the matter is red, for example. So we are speaking about physical property. The color, the melting point, the boiling point, the density, the mass of the matter, the length, the volume, shape, solubility, conductivity. All of these items are physical properties of the matter. Okay? But when I'm speaking about the chemical properties of the matter, I mean that what or how this matter will do when it will react with other elements or other matters. So, for example, how this matter will react in air, in the presence of air, or in the presence of acids or bases, or even when it reacts with water. This is meaning the chemical properties. How does the substance reaction to the presence of acid, bases, other chemicals? We will differentiate between what the meaning of physical change and what chemical change. In a simple word, if I have a matter and it has been changed, but the identity of the matter is the same, so I say that what happened is just only physical change. For example, the physical, if I have, like put this example in our mind, if I have a ice, that's water, when it will be melted, it will stay it is water, but that's physical change. If I have a piece of paper and I started to cut down into small pieces, still the same paper. Okay, so physical change occurs in the substance if there is a change in the state or change in the physical shape of the matter, but there is no change in the identity and the composition of the substance. So that's the physical change. While chemical change takes place if the original substances will be changed completely to one or more new substance with new chemical and physical properties. So the new born matter is completely changed or completely different from the original one. So I have an original substance or original matter, and it gives another new one. And this new matter is completely changed. It completely has a complete physical and chemical properties. Another thing that in the chemical reactions, the covalent and the ionic bonds that hold the elements together are broken and the new bonds are formed. And we are going to see that when we are going to speak about the chemical reactions. Some examples of some physical changes that when the water boils to form water vapor, when the sugar dissolves in the water, when the copper is drawn into thin copper wires, when the paper is cut into tiny pieces, all of that are examples of physical changes. But changes like caramelizing sugar, formation of larva. We will see the original matter or substance will be changed to a new substance which has chemical and physical properties different from the original matter. Let's have an let's concentrate our talking about the chemical reaction or the chemical change, and we want to speak about the evidence that change or the chemical reaction happens. If I have two substances like this one is A and this one is B, and I add A to B, and I can see the change in the color, that's evidence. One evidence as chemical reaction. Or maybe the production of heat or light. So the production of heat or fluid is also evidence of chemical reaction. If I have air bubbles, so the air bubbles is evidence that there are chemical reactions and chemical changes had been happening. Also, when I add this like another material like for example, A to B, and I notice that there will be a solid material precipitated at the bottom of the tube. So the precipitations, that's an evidence of the chemical reaction. When the chemical reactions happen, it is difficult or impossible to so now we talked about the first learning goal, the second learning goal. That's the most important. We are going to speak about how to write balanced chemical equation. Let's start with the idea to identify what is the chemical changes. Chemical change occurs when a substance is converted into one or more new substances that have different formulas and different properties. So again, chemical changes means that a substance is converted into one or more new substances. And these new substances have a different formula and different properties. For example, when the carbon react with the oxygen to give carbon dioxide, the properties of the carbon dioxide and the chemical formula of the carbon dioxide is different from the initial reactants. Okay, so let's talk about the chemical equation, which represent a story about the reaction. So the chemical equations is how to write how the reactant or the chemical reactions takes place. On the left side, we are going to write the reactant. Maybe it is more than one, so we are going to add a plus sign. On the right side, we are going to write the products. And also, if I have more than one, I'm going to separate between them with the plus sign. So maybe I have more than one product, so I will add another one and another and so on. I draw an arrow. The arrow separate between the reactants, which is on the left side, and the products on the right side. Sometimes we add on the arrow, we draw some signs which indicate, for example, this sign, delta sign, represent that the heat is used to complete this reaction. It is very important at this side, beside the reactant, we add between parentheses, we add the physical state. So beside every compound, we are going to write the physical state of it. We have, but we put it between brackets and we use symbols. The S symbols between brackets mean that this is solid. The L, lowercase l, represent the liquid. Lowercase g represent the gas. AQ between brackets mean that it is aqueous solution, and that means this material is dissolved in water, or this substance is dissolved with water. So we have four symbols which represent the physical state of the compound. However, it is the reactant or product. To balance the chemical equation, we are going to place in each form. So we are going to coefficient here. This side. So the coefficient is the coefficient of 1 is typically of. So if it is 1, we are not going to write it. What is the meaning of balanced equation? Balanced equation of atoms of the on the this is the reactant side is equal to the total of atoms. Let's have an example. We have one atom of two atoms molecule of carbon dioxide. This one is the total number of atoms is 3, and the total number of atoms here it is also 3. So that is the meaning of balanced equation. The total number of the reactants equal to the total number of products. So how we are going to balance a chemical equation? The first is to write the symbols with the correct form, as we learn it. If it is for molecular, we are going to write in a correct way. The second step, we are going to count the number of atoms of each in the reactants and the product side. This is the third. I'm going to use coefficient to balance. I'm going to check my find to confirm. Let's have. This is the reaction between this is oxygen, carbon black, and hydrogen. So this one is C, and we have 4 hydrogen. So that's the methane, which is a gas. And also this is O2, which is oxygen. And when we are going to write O, I have to write it, it is O2, because oxygen is Hofbrinkel. So it must be diatomic molecule. So I have to add the subscript 2 here. So this number is a subscript. That's sorry, this is should be arrow. That's also will be arrow. This is will be give CO2, carbon dioxide, which is a molecular compound, and this is H2O, which is the water. Okay, so what I'm going to do, I'm going to separate between the reactants and the products. Then I'm going to write the elements I have. I have carbon, hydrogen, oxygen. I'm going to count the number of atoms on the reactant side. For the carbon, I have 1 atom. On the product side, I have 1 atom. So this, the carbon is balanced. So I have 1 here, I have 1 here. So it is balanced. Let's see the hydrogen. The hydrogen, I have 4 atoms on the reactant side. But on the product side, I have 2 atoms of hydrogen. That means that it is not balanced. To balance that, I'm going to draw or put a coefficient, which is a number, to make it balance. I'm going to write number 2. So these two mathematically will be multiplied with the hydrogen, which is 2. So that would be 2 times 2 is 4. So now the hydrogen atom, it is here, it's 4. On the other side, it's 4. But when I put the coefficient 2, that means it multiply with the hydrogen. It's also mathematically must be multiplied with the oxygen. All the hydrogen atoms on the product side had been changed. It's not now 3. It becomes 4. So now the number, because this is 2 and now that's 2 also, so the total number of atoms of the oxygen is 4. On the product, on the reactant side is 2 atoms of oxygen, like that. So to make it balance it, I have to multiply, to add a coefficient 2 here also. So now the numbers of the atoms of oxygen will be 4. So now I have 4 in this side and I have 4 in this side. Let's count the total number of atoms to check if it is correct. So 1 and 8, so that will be 9 atoms, and that will be 9 atoms. So that will be to confirm that this is balanced equation. And I'm going to write them now like that. But finally, sorry, that will be arrow. I'm sorry, I don't know why. When I changed the PowerPoint, the arrow didn't show. I will write the physical state also, like this is gas, and this is the oxygen is gas, between brackets, carbon dioxide gas, and the water will be liquid, between brackets. So I will put, and this is the balanced chemical equation for this reaction. Finally, like if are going to run the reactants or the products, I noticed that there is polyatomic ion. And we talked about the polyatomic ions previously in week 6. So when I found polyatomic ion, we have to think about the polyatomic ion as individual element, like one unit. So I'm not going to separate P and O. I'm going to consider this as phosphate ion. And what is the charge of the phosphate? It will be 3 minus. So I'm going to think about the phosphate on the both sides as one individual element. And that's it. And thank you very much for your listening, and see you in the class on Thursday.